Good morning. It's November 14th, and this is your daily brief in science. Here's everything you need to know. Recent research from Case Western Reserve University is shaking the foundations of our understanding of galaxy formation. Published in the Astrophysical Journal, the study unveils the existence of 3 ultramassive galaxies, referred to as red monsters, which formed over 12.8 billion years ago, shortly after the Big Bang. Each of these galaxies boasts a mass 100 billion times that of the Sun, challenging the conventional dark matter-centric models of galaxy formation. These galaxies demonstrate an unusually high star formation efficiency, converting approximately 80% of their gas into stars. This finding contradicts traditional models that suggest only about 20% of gas is typically transformed into stars. Expectations for the James Webb Space Telescope, or JWST, were to uncover many small galaxy precursors. However, it has instead detected larger and brighter structures at higher redshifts than anticipated. The JWST's surprising results in its early years indicate that our understanding of cosmic history may require significant revisions. The findings lend support to the theory of modified Newtonian dynamics, or monde, which offers an alternative explanation for the formation of these early galaxies without invoking dark matter. Interestingly, these large and bright structures align with Mond's predictions made over 25 years ago regarding the early emergence of massive galaxies. The research, co-authored by Federico Lelli, J. Frank, and James Schombert, adds to the ongoing debate about dark matter's role in galaxy formation. A separate study identified Rebels 25, a galaxy similar to the Milky Way that formed when the universe was just 700 million years old, further complicating existing models of galaxy evolution. Lead author Mengyuan Xiao emphasized that these unexpected properties necessitate a revision of our understanding of early galaxy formation, with potential implications for the field of physics that could reshape our comprehension of cosmic structures. An experimental DNA vaccine targeting triple-negative breast cancer has shown promising outcomes in a recent clinical trial at Washington University School of Medicine. Researchers developed personalized vaccines by identifying unique genetic mutations in each patient's tumor, focusing on altered proteins known as neoantigens that stimulate immune responses. The trial involved participants who had residual tumors following chemotherapy, placing them in a high-risk category for cancer recurrence. The objective was to train their immune systems to recognize and attack these specific mutations. The vaccine demonstrated good tolerability, with only one grade 3 adverse event reported, while most side effects were mild, including injection site pain and myalgia. Results from this small clinical trial revealed that personalized cancer vaccines were effective in the majority of cases. 14 out of 18 patients exhibited an immune response, and 16 remained cancer-free after 3 years. Those receiving the personalized vaccines had a notably lower chance of disease recurrence compared to patients undergoing conventional treatments, which often come with significant side effects. Triple-negative breast cancer accounts for 10 to 15% of breast cancer cases in the United States, and is recognized for its aggressive nature and high mortality rates, particularly among African American patients. This Phase 1 trial is significant as it specifically targets TNBC, typically characterized by a low mutational burden relative to other cancers. Senior author Dr. William Gillanders highlighted the aggressive nature of TNBC and the potential of immune therapies, noting a gap in systemic therapies beyond chemotherapy for high-risk patients. Dr. Gillanders remarked that the trial results exceeded expectations, but emphasized the necessity for ongoing randomized controlled trials to compare the vaccine with standard care. The software utilized to select neoantigens, named PVACView, predicts neoantigens based on tumor DNA mutations and immune binding capabilities, and aims to be made widely available for cancer researchers and clinicians. Further studies are planned to explore this innovative vaccine strategy. A groundbreaking study published on November 13, 2024, has unveiled what may be the oldest known spindle whorls, dating back 12,000 years, found at the Nahal Ain GV2 archaeological site in northern Israel. This discovery could reshape our understanding of early technological innovations, particularly in relation to the invention of the wheel. Researchers Talia Yashuv and Lior Grossman from the Hebrew University of Jerusalem documented around 100 spindle whorls, which were essential for spinning textiles from natural fibers like flax and wool. Experiments with replicas of these pebbles confirmed their effectiveness in spinning, especially flax, indicating that early humans were experimenting with rotation technology well before the wheel was developed. Spindle whorls are round, weighted objects designed to aid in the rotation of spindles, thereby facilitating efficient yarn production. The study meticulously analyzed 113 stones, featuring holes drilled from both sides to ensure balance during spinning. These holes, measuring 3 to 4 centimeters in diameter, were created using a flint hand drill. Modern technology played a crucial role in this research, with digital 3D models employed to analyze the pebbles, primarily made of limestone and characterized by their circular shape and central perforation. The researchers noted the importance of this technology in understanding the innovations of prehistoric craftsmen and how they relate to modern advancements. However, the study did not include trace analysis to definitively confirm the use of these stones for spinning, a limitation acknowledged by the researchers. Skepticism also arises from experts like Carole Cheval of Côte d'Azur University, who suggested that older similar objects might exist and pointed out the lack of microscopic evidence of use. The findings imply that these spindle whorls could have influenced the development of later rotating technologies, such as the potter's wheel and the wheel for carts, which were pivotal for early human civilizations. The research team ruled out alternative uses for the pebbles, such as beads or fishing weights, based on their size and material characteristics. This significant archaeological finding not only illuminates early textile production, but also hints at the technological advancements that laid the groundwork for future innovations. A recent study published in The Lancet has revealed a staggering statistic. Over 800 million adults worldwide suffer from diabetes, nearly double previous estimates. This surge in diabetes prevalence is alarming, as it has increased from roughly 7% in 1990 to 14% in 2022. The rise is particularly pronounced in low- and middle-income countries, where access to care remains limited. Among adults aged 30 and older, a significant 59% were untreated for diabetes in 2022, indicating substantial disparities in diabetes management. Despite the growing number of cases, treatment rates in these regions have not improved significantly, leading to a stark contrast in diabetes care compared to wealthier nations. In sub-Saharan Africa, the situation is dire, with only 5 to 10% of diagnosed individuals receiving the necessary treatment. India currently holds the highest number of diabetes cases, with 212 million affected adults, followed by China at 148 million, where treatment coverage is notably better. Contributing factors to the rising rates of type 2 diabetes include obesity and poor dietary habits, especially in regions where these issues are prevalent. Dr. Tedros Adhanom Ghebreyesus of the World Health Organization has stressed the urgent need to address this diabetes epidemic, which has escalated alarmingly over the past 3 decades. The WHO has established global targets for diabetes care to be achieved by 2030, focusing on enhancing access to diagnosis and treatment, particularly in Africa. The study, conducted by the NCD Risk Factor Collaboration and the WHO, analyzed data from over 140 million people across more than 1,000 studies worldwide, highlighting the critical nature of this public health challenge. On November 14, 2024, researchers published a study in *Geochemical Perspective Letters* that sheds new light on the Lafayette meteorite, a rare specimen that originated from Mars. This meteorite was ejected from the Martian surface approximately 11 million years ago due to an asteroid impact and eventually landed on Earth near Purdue University. The Lafayette meteorite was rediscovered in a drawer at Purdue in 1931, making it one of the few meteorites that can be traced back to Mars. Researchers utilized organic contaminants to narrow down the meteorite's fall year to around 1919, although the exact timing remains uncertain due to its unusual discovery history. The study, led by Marissa Tremblay, found that the interaction with liquid water likely resulted from melting subsurface ice rather than from abundant surface water. their analysis identified minerals formed during contact with liquid water, supporting the hypothesis of subsurface interaction. Importantly, the researchers confirmed that the age of the water-rock interaction was unaffected by the meteorite's journey through space or its entry into Earth's atmosphere. The study established that the Lafayette meteorite interacted with liquid water approximately 742 million years ago, providing significant insights into Martian geology. Meteorites like the Lafayette serve as time capsules, offering valuable geological data through their mineral composition and isotopic analysis. This research involved collaboration among various institutions, highlighting an international effort to study the Lafayette meteorite and similar Martian specimens. Looking ahead, the team plans to apply similar dating methods to other meteorites and potentially to other planets in the search for signs of water. Co-author Ryan Ickert emphasized the unique evidence of water interaction found in the meteorite, clarifying the timeline of its aqueous alteration. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.